Okay, everybody, this lesson is on radicals. We dealt with simplifying square roots in a previous chapter, but we're going to extend that now to cube roots, fourth roots, and so on. If you recall, square root of 36 is 6, and the reason for that, if someone were to ask you why, is because if you take 6 and you square it, you get 36. Now some of you might say, well, isn't the square root of 36 also negative 6? Because after all, if you take negative 6 and you square it, you do get 36 as well. And you would be right. The square root of 36 actually has two answers, positive and negative 6. However, if they want both answers, they will put a plus or minus sign in the front like that. We're not going to see that much in this chapter, but in a later chapter we'll have to use that. If they want the negative answer, they will put a negative sign in the front, right there, and then I give them the answer negative 6. If they want the positive answer, then this is like the first one here. They're not going to put a plus sign, they'll just leave it blank. And our answer is positive 6. The positive answer is what's called the principal root. It's the principal root. And this one is the negative root. So square roots actually have two answers, a positive and a negative, but usually we just want the positive answer. All right. We can also have cube roots, as well as fourth roots and fifth roots. For instance, the cube root of 8 is 2, and the reason for that is because if I take 2 and I cube it, I will get 8. The cube root of 64 is 4, because if I take 4 and we cube it, we get 64 back. Fourth root of 16 is 2, and the reason for that is because if I take 2 and I raise it to the fourth power, I get 16. Fourth root of 81, what number, if you raise it to the fourth power, gives you 81? That number would be 3, because 3 to the fourth power is 81. Okay, in general, what we have is this. The nth root of a equals b means if I take b and I raise it to the nth power, I get back a. That's what we've been doing. By the way, the little number in there is called the index. And so notice here is my index was 3. Here my index was 4. For square roots, the index is actually a 2, though we don't write it in. The index can be any positive in any whole number greater than or equal to 2. Let's look at some more examples now. Simplify. Suppose I have the square root of 16. We want just the positive root, so that's a 4. Square root of negative 16. Now you have to think, what number can I think of when I square it will give me negative 16? And there is no number that's going to do that. And so what we would write for this one is that this is not a real number. Not a real number. The easiest way to remember that is you just can't take the square root of negative numbers. And also it doesn't work for any even root, actually. For instance, if I want the fourth root of negative 81, what number can we think of that when we raise it to the fourth power will give us negative 81? There's no real number that does that. So this is also not a real number. So in general, what we have is this. If n is even, and a is greater than, a is less than 0. So we have an even root, and the number under here is less than 0. It's negative. The nth root of a is not a real number. On the other hand, if a were odd, for instance, the cube root of negative 8, well, that actually is a negative 2, because negative 2 to the third power does indeed give you a negative number. The cube root of negative 27. What number, when you cube it, gives you a negative 27? The answer is a negative 3. Negative 3 to the third power gives you 27. Okay, one more here. Fifth root of negative 32. What number raised to the fifth power will give you a negative 32? That answer is a negative 2. Negative 2 to the fifth power is a negative 32. Okay, so you cannot take the even root of a negative number, but you can take the odd root of a negative number. Let's now look at the graphs of a couple of these radicals. Let's graph f of x equals square root x. We're just going to make a table of points here and then plot them. If I plug in 0, or actually if I try a negative number, for instance negative 1, remember the square root of negative 1 is not a real number, and that means that we can't plot it. I've got to start at 0. If I plug 0 in, the square root of 0 is 0. If I plug in a 1, the square root of 1 is 1. If I plug in 2, the square root of 2, I need a calculator for that. I think it's about 1.4, approximately. I could skip to 4. The square root of 4 is 2. And I could go on, for instance, if I go to 9, the square root of 9 is 3, and so on. Okay, so let's plot these points and see what we get. 1, 2, 3, 4. 1, 2, 3. 2, 3. Okay, 0, 0 is the first point we can plot. There it is. 1, comma 1. 2, comma 1.4 is about here. 4, comma 2 is around there. And 9, 3, I can't really fit it on here. Connect the dots, and that's the graph of y equals square root x. All equations that have square root x in them, when we graph them, are going to look similar to that. Notice it actually starts at 0, 0 because there's nothing on the left side. Let's compare that now to graphing f of x equals cube root x. Table of points. Now with cube roots, remember you can take the cube root of a negative number. So for instance, if I try negative 8, the cube root of negative 8 is a negative 2. We talked about that earlier. The cube root of negative 1 is negative 1. The cube root of 0 is 0. And I also get 1, 1, and 8, 2. All those points I can plot. Let's see what they look like here. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5. 1, 2, 3, 5, 6, 8. Okay, negative 8, comma negative 2 would be way out here somewhere around there. Negative 1 is about here. 0, 0, 1, 1, and 8, 2. Now if I connect these dots, I get a curve like that, which sort of looks like the square root function, but then we also have this part here that we did not have with the square root function, like that. And that's basically what our cube root function looks like when we graph it. Okay, moving on. if I have the square root of negative 3 squared, and I try to simplify this, underneath the radical sign, negative 3 squared is actually a positive 9, and the square root of 9 is 3. So notice what happened here. The square and the square root sort of cancel each other out, but I'm not left with a negative number. I get the positive number. If I have the cube root, let's say, of a negative number, negative 7 cubed, negative 7 to the third power is 343, and it's actually negative 343. And then if I take the cube root of that, I'm going to get negative 7. So actually what happened here is the cube root and the cube actually cancel each other out, left with the negative 7, which I have here. The rule for that is this. If n is even, then the nth root of a to the n, the nth root and the nth power sort of cancel each other out, but what comes out must be a positive number, and so we must put absolute values on it. That's only for an even n. If n is odd, then the nth root of a to the n is actually just a. It could be positive or negative depending on what a is. Let's do some more examples of that. For example, the fourth root of negative 5 to the fourth. Since this is an even root, fourth root, the answer, according to our little rule we wrote there, is the absolute value of negative 5, which is 5. The sixth root of x to the sixth. The sixth root and the sixth power sort of cancel each other out, but it leaves you with the positive number, so I have to put absolute values on the x. The seventh root of negative 3 to the seventh power. Since the root is even, the index is, since the index is odd, 7 is an odd root, our answer is just the number in there, negative 3. Okay, so I use this fact right here. If I have, let's say, the ninth power, or the ninth root of negative 5 to the ninth power, since the index is odd, it's just negative 5. A couple more examples. The square root of r squared. Since we're dealing with an even root here, its absolute value r. Negative fourth root of 16. The negative sign's on the outside. 16 can be thought of, 16 is actually to the fourth power. So this is negative 1 times a 2, which is a negative 2. The negative sign was on the outside. The fifth root of negative 243. Well, negative 243 is actually 3 to the fifth power, negative 3 to the fifth power, that is, like that. And so according to that rule, we have an odd index, and so this is just negative 3. A couple more. The sixth root of negative p to the sixth power. Since the index is even, this is the absolute value of negative p, which is, you can leave it like that, or the absolute value of p. You don't know what p actually is. It could actually represent negative 5, so I have to keep the absolute values on it. The sixth root of y to the 24th. Now, one way I can simplify this is think of y to the 24th as y to the 4th to the 6th power. Since these are the same, I can use the rule that we've been using. It's an even index, it's an even root, and so the answer is the absolute value of y to the fourth. Now anything to the fourth power is already positive anyway, and so I could take the absolute values off here and write y to the fourth. And last one, the fourth root of x to the 12th. You can think of x to the 12th as x to the third to the fourth power. These are the same, and so according to our rule, since it's an even index, an even root, this is the absolute value of x cubed. Okay, and I believe that ends our first lesson on radicals.